Hi everyone. Okay, so we're going to continue with lesson 9.5. We're going to start down here, okay, where it says core concept, discriminant. But if you notice, I have something, so that's where we're going to start. But I put this equation in up above. So if you just scroll up above, these are the three we already did. We did number 3 towards the end. We ran out of time, but we had set it up so you could just put the rest in your calculator. But now I've added in this new problem because I want to show you the third option that hasn't appeared yet, but it will be appearing for the second half. So let's just revisit what we did. A equals 2, B equals 1, C equals 5. All right, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now when I sub my values in, I get negative 1 plus or minus the square root of 1 squared minus 4 times 2 times 5 all over 2 times a, which is 2. All right, so now I'm going to simplify. So I get negative 1 plus or minus, and underneath here, 1 squared is 1, minus, and when I simplify the next portion, 4 times 2 times 5, 4 times 2 is 8, 8 times 5 is 40. It kind of looks like a 9. Okay, all over 4. Now, my next step gives me negative 1 plus or minus, and underneath here I get negative 39. Well, at this point, I can't take a square root of a negative, and we talked in a previous lesson about how that's an imaginary number. So I'm done, and that means if I were to graph it, and I don't know what this one looks like per se, but that means it's not going to touch my x-axis. So in this case, we would say no real solutions. Okay? Now what we're going to look at in this next part is how to figure out how many solutions you have right off the bat. So this value underneath here, this b squared minus 4ac is called something special. It's called a discriminant. Why don't you say that? Discriminant. Yeah, say it again, discriminant. Okay, so that value tells us a lot because, first of all, if the number under the square root is greater than 0, so let's say you do a problem, Let's pretend we worked it all through, we're simplifying it, and we get to a point where we have something like x equals 4 plus or minus the square root of 16 over 2. I'm totally making this up. But when this number underneath the square root is positive, then that means we're going to have two answers. Because this would continue, would keep going with the problem and say 4 plus or minus 4, because that's the square root of 16. And then we said would break that into 4 plus 4 over 2 and 4 minus 4 over 2, and we would get our two answers. So you're going to get two answers when that value underneath here is greater than 0. Okay? All right, next scenario. Let's say you go ahead and you work it all the way through and you get x equals 5 plus or minus the square root of 0 over 2. Okay, again, totally making it up. Well, the square root of 0 is 0, so when you go to simplify that, you just get 5 plus or minus 0. Well, 5 plus 0 and 5 minus 0 are the same thing, so you only have one answer. Well, that means your graph just hits the x-axis at one point. Okay, so what we find is that if this value underneath the radical sign, if this here, again, it's called a discriminant, if it equals 0, we only have one solution. Now, we don't know what that one real solution is, but we know we have one. Okay, so we've looked at two real solutions when it's greater than 0, one real solution when it's equal to 0, and now, like in that one we just did above, when this value under the square root, again, the discriminant, when it is less than 0, then what that means is that, like we said, there's not going to be any solutions. So if I have something that appears to look like x equals 10 plus or minus, and it doesn't matter what's in here, but if it's negative, then this can't exist. There's no real square root that works there. There's no value. It's an imaginary number. So that means there's no real solutions, no x-intercepts. So the advantage to understanding what a discriminant is if you just want to know how many solutions you have, if you're doing a word problem or something, and you just quickly calculate this value, if it's greater than 0, you know there's two answers. If it equals 0, you know there's only one answer. And if it is negative, so it's less than 0, you know that there's no answer. Okay, so let's practice that. In example 2 here, it says interpret the discriminant, determine the number of real solutions. Again, real is key here because there are imaginary solutions, something different, but we're just working with real numbers of the equation or function. So this is an equation, this is an equation. F of x, we haven't seen that in quite a while, but that's a function. We're going to approach it the same way though. All right, I'm going to look here and I'm going to do my A, B, and C. A is 1, B is 8, C is -3. Now all I need to do, because all I'm doing is determining the number, not what they actually are, I'm thinking about the discriminant, the number underneath the radical. Remember it was -b plus or minus the square root of b squared minus 4ac over 2a. This is what the original thing is, but I only need to focus on this here, okay? So that means when I calculate the first one, it's going to be 8 squared minus 4 times 1 times -3. 64 minus 4 times 1 times -3 is -12. 64 plus 12, it doesn't even matter what it is. We can write that it's 76, but it's a positive number. So that means this here, my discriminant is greater than 0, so I have 2 real solutions. And that's my answer. All right, let's try letter B. Again, I'm only focused on the discriminant. So I'd find what A is. It's 9. Ooh, this one, I got ahead of myself. Look at this. Not everything's on the same side. It's exciting, huh? So I need to get everything on the same side. I'm going to subtract 6x first. All right, so I have 9x squared minus 6x plus 1 equals 0. So now, going back to where we were, the critical though, I have to get it all on one side. So everything has to be together on one side of the equation to define your A, B, and C. If you have things on the right and on the left, you have to get them together or else you're going to get the wrong answer. Because look at this, when I define A is 9. When I define B is now -6. If I would have went with the original, I would have said +6, so that's not right. So you have to get it all on the same side. And C equals 1. Okay, so putting those together, it's B squared. If it helps you to write it, by all means do so. B squared, I'd actually encourage that. -6 squared minus 4 times 9 times 1. So it's 36 minus 4 times 9 is times 1 is 36. So we get 0. So in this case, my discriminant equals 0. So there's only one real solution. And I apologize for the scratchiness. One real solution for letter B. And we have one left. You can probably guess what it's going to be. Should be a no solution. Let's see. So if they give us a function, f of x, we're evaluating this whenever it's anything that hits the x-axis, which these points are always going to have 0 as our y value. So it's always going to be x, 0. So we're putting 0 in place of f of x. All right, now notice we have an x squared term, an x term, and no constant. So it's not that we have to guess it, it's just that it doesn't exist. That would be like them saying +0. So when I label my A, B, and C, I'm going to say that A equals 1 because of the 1 x squared, B equals -1 because of the -1, and C equals 0. All right, putting that together, B squared minus 4AC. So B squared is -1 squared minus 4 times 1 times C is 0. -1 squared is +1, minus 4 times 1 times 0 is just going to give me 0. And actually, this one works out just to be 1. So they didn't give us an example of a negative. And so we see this is greater than 0, so this must have 2 real solutions. Okay? All right, let's move down to summarize this, and then we'll try 3 just to wrap it up. Okay? Alrighty, so let's take a look. Now the core concept here says that there's 4 different methods for solving quadratic equations. The first was factoring, which we did in chapter 7. I'm going to skip this for the moment. The next thing we've learned about is using square roots, which we did in 9.3. So this method only works when you have x squared and a number, and it can only be used for certain equations. Then we learned the quadratic formula. In this lesson here, you can use it anytime it gives exact solutions, but a drawback is it does take time to calculate. Okay, so again, factoring, straightforward for things that work, but some don't factor out. Square roots only works with certain equations. That can be a drawback, and quadratic formula works all the time, but it does take time to do. All right, I skipped graphing because we are going to cover this in Chapter 8 in detail, and so that's why we did not do Lesson 9.2 right here, because we don't really have the background. Obviously, the book is building in sequential order, but just a lot of the math teacher consensus, we think these could be flipped. So we did 9 first. All right, we have three problems left. And this just says choosing an efficient method. Now you could do quadratic formula every time, but it's not always going to be the best method. They want us to solve the equation, use any method, but then explain your choice. So I'm going to look at this one. I have an x squared and x, a constant. Maybe I can factor it. Let's just see. So there's no GCF. I can say x and x. Now two things that multiply to give me negative 12, but add to give me 11. How about 12 and negative 1? 12 times negative 1 is negative 12, and 12 plus negative 1 equals 11. So it works. So now I set both of these equal to 0. I'm going to subtract 12 on both sides, x equals negative 12. I'm adding 1 on both sides, x equals 1. I have my two answers. Two solutions. I chose to do factoring because I think that was the most straightforward. It was quick. The numbers were easy, meaning that this was a 1x squared. When that's a 1x squared, that makes it really nice to just kind of mentally think through. All right, let's try letter B. Now in looking at this one, I have an x squared term, and then I have some constants. I don't have that x term in the middle. So first of all, I'm going to get everything together. And once I do that, sorry, that disappeared, and I don't know why. If you needed those lessons, oh, here we go again. If you needed, there we go. I was going to say, just rewind the video, but we're back. All right, so I'm going to get everything on one side. Well, I can subtract. I could do it that way. Instead, I'm going to use the square root method. Now notice, in me talking it through right there, there's more than one way to do it. I could have gotten everything on one side, factored, and gone from there. Or I can say, no x squared method like I had said before. No x value, I mean. So let's see if we can do the square root method. I'm going to add 5 to both sides. So now I have 9x squared equals 9. We said the square root method is synonymous with isolating the variable. So I divide by 9. We get x squared equals 1. So we take the square root, and x equals the square root of 1, which is 1 and negative 1. So both answers, negative 1, are my solution there, okay? We can't just use the discriminant in this case because they're not asking us how many solutions. They want to know what are they. Solve the equation. So I chose using solving by square roots in this case because there's no x term, okay, in that scenario. All right, let's look at the last one. All right, 5x squared minus x minus 1. I can't use square root method because of this x, so that's out. If I choose to try to factor, I have 5x and x, the only things that multiply to give me 5x squared. Two things that multiply to give me 1, negative 1 are 1 and negative 1. And if I try this out, let's see, that's going to give me negative 5. That's going to give me 1. That doesn't work. Let's change our signs. Now maybe you're thinking, let's just jump right to quadratic formula. And that actually is going to be the better option because this doesn't look like it's going to factor out. This is not going to give me an answer if I choose factoring because that means that my zeros, where it crosses the x-axis, must be some crazy numbers, some kind of decimal that's not friendly, okay? All right, so it's all in standard form. A equals 5, B equals negative 1, C equals negative 1. So negative b plus or minus the square root of b squared, oops, we're close to the end, minus 4ac over 2a. All right, so negative 1 plus or minus negative 1 squared minus 4 times 5 times negative 1 over 2 times 5. I'm going to get 1 plus or minus negative 1 squared is 1. Minus 4 times 5 is 20, times 1 is negative 1, so negative 20. all over 10. And when I simplify that, I get 1 plus or minus the square root of 21 over 10.